Yeah, here's another video, guys, and a light that's causing me troubles. I need to get a new bulb. As promised, I'm going to do another video on this RE45 RCA. That's its actual model number. I'll show how the tuning works on it, and we'll go over what I've done so far with the power supply and a few problems I had to overcome. So, start off with, this is out of the radio. I've already took the bolts loose on this side. This just lifts off. It's just a piece of sheet metal, which appears to be either extremely dirty, which it is, but also kind of looks like there's been brush markings on here, like someone tried painting it with some other color, which I think they did. Anyway, it's got some rust. It's not a real big deal. The front of the radio, which I took off also, is right here. The power switch would go, oh, sorry about that shine, right in here. This is just a plastic piece that's screwed in. It may be wood, I don't know. Actually, it could be wood, actually. Anyway, and then of course volume control, and then over here is where the switch that would be used for the switching between radio and phonograph. And then of course tube sockets. There's little holes here. Here there's one that you can't see behind here, and one over in that area there. That's for adjusting it, neutralization, adjusting the neutralization so it doesn't oscillate. And I want to go into that a little bit about how they want you to do that. Some rust. I'll probably pull back this cable, take it loose a little bit, and pull it back, and clean this up a little bit, touch it up with some primer or something. Just, I mean, once the shell's back on top, the piece on top, you'll never notice that what's underneath here as far as color goes. Now when you rotate this, you move the dial, all you're doing is moving this big drum. I'll show you what is going on the bottom side. Get it rotated around here so you can see it a little better. Got a pretty nice little cable here. Now these had cans over. They're copper, and then they painted them. So there's 4 of them. Now if you watch the caps and watch down in here, that's how it works. Now these are fit against, there's rollers on the other side that they ride. They're actually only pivot here. Springs keeping tension on them. So that's how they work. Now it's pretty stiff. It needs good cleaning and lubrication. You have the coils, and of course the tuning capacitors, and then down in the this area here, this is where that pattern capacitor is, or trimmer for neutralization, and then there's a resistor inside here that I'll have to check. But as you rotate that, it opens up and closes caps. Now those are the 4 little pivots. That's what these adjustments for, is to keep these, they ride in there, a little bearing on there to keep them exactly where they need to be. So it's kind of like a fine adjustment for the overall adjustment of it. Hum control. There's 3 caps in here that'll have to be most likely replaced. These 2 micas are probably okay. I'll check them. Now on the power supply, it had 3 dog bone resistors on it. They all were right, exactly the value they're supposed to be. So I'll check these and the ones that's underneath. There's not a lot to it, but I'll check what resistors there are to make sure that they're where they're supposed to be. This switch here is the let's see if you can see the action on that, but that's the phonograph radio switch. The volume control has been replaced. It's a dual pot and it's been replaced, but I checked the value on it and it seems to be pretty darn close. It calls for 3,800 and these are 4,000. It's close enough. But so someone, it originally had wire wound potentiometers in them. But other than just cleaning and lubrication and things of that nature, need to clean up the dial here. There's 2 screws that you can come in from the back that loosens these brackets up, and then you can take this part out, and then that's how you get to the light bulb, which it doesn't have a light bulb in it. The light bulb runs off full line voltage, so I'll have to get a light bulb for it. This thing is supposed to be designed to rotate this, rotate the knob, and for it to go for like fine tuning, or you can override it and go. But with it being pretty stiff, needing a good cleaning and lubrication, it's not wanting to work exactly perfectly. You can see some of the dirt that was in here. This thing was actually had just dust, just a lot of dust in it, and I cleaned a lot of it out. Now let's go and look at what we're doing with the power supply chassis and stuff. I've removed everything off the top, mainly because I had to. This thing just had tar all over it, and this is where the power transformer set. When it shorted out and overheated, so I had to get that cleaned off. And I figure on just repainting this. Now the interesting thing about this, and of course you can notice where all the cans sit was never painted, and this is a brass chassis. It's full brass. But the 2 main audio transformers are in a brass housing too. But wherever the other cans came up, there's no paint. So what they had done is they actually put the whole thing together, did a little masking around the sockets and stuff, and then they just painted it. And not very good either. see if I can kind of zoom in on a couple little spots here. I don't know if you can see it very well with the lighting in here, but there's a little brown paint. I don't know if I can get that on there, but there's overspray on this socket right at this edge and a little bit along the side here, as well as some around this edge here, some in here, and right in here. And I'm not sure if that's like a run right there. The metal holder is painted on this side, partially painted on this side. And when I started cleaning one of the sockets up a little bit, I noticed there was some brown right in there. And I'm not sure if you can actually see that or not. But I thought it was kind of interesting. As a restorer, and if I'm going to paint something that has parts in it I don't want painted, I spent a lot of time masking and cutting the masking and getting it just exactly right so I don't get any overspray. Yet the factory had some overspray. They didn't get it masked extremely well. So I found that quite interesting, and the fact that they just put it together and sprayed it. Now, to be an advocate on them, the customer don't care. I mean, as long as it's painted, that's all that matters to them. It's the cabinet that they care about. You know, does the cabinet look nice? Because that's what they're going to look at. The only way you're going to see this thing is when you go around the back side of the radio and look in it. And when it's in someone's home, it's going to be up near, pretty much up against a wall or close to a wall and sitting there and playing. All they care about is that cabinet looks really nice. You know, it's got a real great finish on it, real great woodwork on it and everything. And the thing does what it's supposed to do. You know, if they're listening to radio, the radio works good and the record player works good. That's all they care about. They're not as concerned that, you know, when they see this at the showroom or wherever, you know, at the dealer, or when it gets there to their place, everything's going to be plugged in. So you're not going to see overspray or anything. But it is kind of curious that if you're really going to repaint this thing, which I'm going to, but if you really wanted to be a stickler for it to be in exactly the way it was from the factory, then you'd have to try to recreate the overspray. The other interesting thing about I already took the plate off because I'm going to paint it, and that was easy enough to take off. It's not riveted. It's got, what they are is what they call twist lock screws or rivets, and there's the plate, and these are the little locks, rivet like. They screw in, basically. They got a twist in them, and when you drive them in, they just twist in. Getting them out's real easy. And so anyway, I took that off. You got a hum control also on the power supply chassis and audio chassis. So there's two hum controls. One is actually located on, I believe, on the detector, and the other one is located on the first audio. Then the other interesting thing is there's a tone control, and the tone control is actually got to have a screwdriver. I've got it out because I had to have it out to remove some stuff underneath here. But it's just a rheostat with a screwdriver fitting, and according to the service info, this is set at the factory, which is a rheostat wire wound, and it's, you know, and they say just not to really bother it. It should be okay because it was set once at the factory, and that's all it should ever need to be done to it. So I found that quite curious. One other thing I wanted to talk about on that, just kind of a side note. The hum control is your standard wire wound, and I don't know if you can see all three connections, but just standard potentiometer. You got three connections, two outsides. It goes has the full resistance, and then your center wiper. standard potentiometer like a volume control, a lot of tone controls, things of that nature. That's a potentiometer. This has only two connections, here and here, and one's going to the wiper, one goes just to one end of the winding. You notice here the winding does not go all the way to here. This is a rheostat, or variable resistor. And I could back this thing out, I forgot it zoomed in. But that's what these are actually rheostats. And where the others are potentiometers, so I just wanted to kind of point that out. I hear them used interchangeably, but now you can use a potentiometer as a rheostat. You just have a third leg here, you just wouldn't hook up. Now, I've been debating about exactly how to do this. I mean, there's a little corrosion inside, you know, but it's cleaning up pretty good. There's some way up in here and some in here, but I'd like to, I've been debating about actually just removing everything, cleaning it. I don't want to paint it per se, but doing a clear coat on it possibly, at least on the underside here. But I haven't actually, you know, there's some little minor issues about doing that. You have to make sure you get your grounds again back in there, so you'd have to scrape and do things of that nature. But also removing these rivets here, there's 3 rivets. It's one long strip for the sockets, and there's 3 rivets that are located here that are actually grounds, and these resistors hooked to them, and so they're going through here. They really can't make good ground contact on the other side. This is the only place they can make contact, is right in here. So I would have to figure out how to overcome that and still look decent. So I haven't quite decided. I may just leave, maybe pull the wiring for the most part and just try to clean stuff as best I can, and then I can also just paint some clear in there or something to protect it. It might not even ever corrode again, I don't know, but it just, I'm still debating on exactly what I want to do there. This area here is where a very large power resistor goes, and that's this guy here. He fits in there, and which ironically is made by General Electric. Now, something else I've also noticed between this and working on that Philco radio that I've been working on also simultaneously, this way they done the cabling in here with the outer cloth covering to hold it all together, and up in here, now this is just colored some right through here. It's basically green, and the interesting thing is the style of wires, this green cloth, the way it's all done is almost exactly like that Philco. So I have thought to myself that maybe possibly at this early, you know, this was built in 1929, and at that era and that time period, that they weren't really truly making up their own wiring harnesses like this, that they might have ordered them from some company that does make them. Just a thought. Or it could be just that green was the most popular color at the time too. I don't know. Anyway, that's it there. And of course, output transformer and interstage transformer between the first audio and the 245s. And then this is the input transformer. This guy here has got two primaries. One primary is for the radio. It's picking up signal from the detector through that switch, and when you flip it over phono, it flips the needle in for the turntable, but it actually goes to a different primary on here to increase gain into the audio amp. And then we have, of course, the choke. Now, a couple other things I want to talk about. One is the power supply, or the transformer. And this thing was a major ordeal. Number one thing though, there was somebody who made a comment about, I appreciate your confidence in me about being able to rewind one, and that would be fine for a small transformer, but made a comment about me rewinding this transformer, and I don't have the equipment for it. It takes pretty decent equipment to wind a power transformer, and especially a heavy duty power transformer. The power transformer that was used in this, you had your primary and you had your high voltage or high tension secondary, your B+, but you also had then 5 filament lines, windings on it. You had the 5 volt for the 80, you had two 2.5 volt ones, one for the 45s and one for the 27 detector, and then there's two 1.5 volt lines, one for the first audio preamp and the other one for the RFs, the other 26 RFs. So that's a lot of windings, and you can't even save the wire even if I wanted to. Anytime you ever tear an old transformer, power transformer or audio transformer apart, one thing you'll find out real quick is when they're getting this age, what ends up happening is you try to unwind the windings, the wires that you need to save, the enamel just cracks and shatters and falls right off. It's done for. It's fine as long as it stays where it's at, but the minute you start unwinding it, it'll just fall apart. So you end up having to buy all the wire you need. The secondary on that, it's 750 volts. So it's probably pretty close. My guess would be somewhere around close to 2,000 feet of wire just on the B+ winding. Primary's probably got another at least 300 to 400 foot, and then of course the filament windings are not quite as long. They're a lot shorter, but they're heavier. But in any case, and then also it was packed in tar. You'd have to get all that tar completely cleaned off, completely off all the plates of the core, get that all completely cleaned up. It would take quite a bit of time, and again, I don't really have the equipment to really spin the thing up because the primary's out and the B+ is out, that secondary, and the 5 volt is not reading right. So the primary is always the closest one into the core, and then you'll have the highest voltage winding next of the secondary. So everything else would have to come off first and then get to those and then get them off and then start afresh. So it would took a lot of work, and I already had transformers I can use. The problem was I didn't have one transformer, I had to use 2. So we made something up. This right here is where the filter caps were. Of course, once they're emptied out, the new ones are a lot smaller, so I had plenty of room. This transformer is sitting right here. That's just for filaments. The 4 main filaments. That's all this is. So that's the 2 1.5s and the 2 2.5s that are sitting on this transformer. what's underneath this guy over here, set in an angle, this is your 5 volt for the 80 tube and the high voltage, the high tension, your B+. And since I was putting the two together and I wanted to get everything back hooked on the original hookup plate, then I had to drill some holes through here and run some stuff on there. I didn't have any rubber, so I used hot glue all the way around it to make a something so it won't chafe, although it's not going to move. Then I actually glued the two transformers together. So they're actually glued together so that they'll go on as one unit once the plates are back in place. And so that I could get the wires from here over to here. Now, I said that I had the 45s, the supply for them, for their filaments, wasn't center tap, and I had to come up with a way of center tapping it. Well, the way you do that is if you don't have a center tap, and you need to get a center tap off that filament, you throw a resistor across. Well, actually, in this case, 2 resistors so that you can tap the center. And the general standard value is between 20 and 40 ohms, depending on what voltage. If it's 3.5 volt, 3.3 to 5 volts, it's usually closer to 40 ohms, or you can generally use 40. 1.5 and 2.5 volts, you use 20 ohms. So it's just two 10 ohm resistors, and they're just located right here. One's here and one's there. Where they come together, that's going to be the center tap. That'll be where the wire actually hooks for the center tap. And from that wire, that'll go to this big guy here at one end. There's a 775 ohm resistance, and that is the cathode resistor, biasing resistor for the 245s. Now, and of course this just shoots down in here. It was held in by tar originally. I'll just hot glue it, and then this snaps on like this. Now, how do I come up with values and everything? Well, partially from experience, but as I've said before, over and over and over, your best source of information you always want to use is tube manual. Tube manuals wrote by the people who made the tubes. They're the ones that engineered them. No one knows those tubes better than they do. So I'll show you a little bit what we got here and show you what's in the tube manual. This is the RC10 number 10 manual. I think it's 1930 or 31. We'll zoom in a little bit here. This is for 45. Here you got, and basically I'm going to show you the schematic of the radio, but this is what I've got. I got two 45s push-pull. There's the output transformer here. Here's the interstage transformer that splits the signal, phase changing. This would go to, they're saying from the second detector, but this is which would act also doubled as the first audio. But this actually, on this radio, goes to a separate tube. 26 is acting as first audio. But the thing I want you to notice, here's the filaments. And they're going down, and they're going to a filament supply that is not tapped. There's no center tap on it. But what they did is they put a resistor in here, or actually it would be 2 resistors or a special resistor that has a tap on it. And then they pull off of that. R here is your biasing resistor, the cathode resistor for self-biasing. And of course that goes to B minus or ground. They tell you what to use. are 775 ohms, which happens to be what's on this guy. And P, center tap resistor, 20 ohms. Now current wise, these guys draw 1.5 amps each. Put together they're 3 amps. But their actual resistance is quite low when they're fully heated up or running and operating, because at 1.5 volts or at 2.5 volts and 1.5 amp is very low resistance. This 20 ohm is actually quite large in comparison. It's about 12 times the size. So what that means is when current is coming in here, this is not the very easy path. The easy path is to go to the tubes. So this is getting about just a little over 1/10 of an amp. About 100 milliamps, a little over 100 milliamps. The rest of the 3 amps is going to the tubes. It works out to be about 2.995 amps. So most of the current's still going there. That small little drop in current is not going to be that much on those. Well, a little current's going through here. I got by with just easily, if you take 1/10 of an amp and I squared R it and take it times 10 ohms for each resistor, it comes out like 0.15 watts. So a half watt is more than enough. Now let's see here. If you remember this circuit, then we'll look at it right here. And let me rotate this a little bit and bring her up just a little bit. And we can kind of probably zoom in just a little more. And there's the same circuit right there, except drawn a little differently. In this case, we have a center tap, but now we don't, since we had to replace the transformer. This line came down and went to R4. R4 is over here. It says 775 ohms to ground. But that's that circuit. 245s, output transformer, interstage transformer, being fed by the 26. And then there's that other transformer, what they call the input transformer. And this winding here is the one that will feed over and goes to the, when it's switched in, it goes to the needle on the phonograph. And this one here is the one that goes back to the 27 tube, the detector, and it's picking up what the detector throws out. And the radio's switched in. So I just wanted to show you the two main problems was trying to fit 2 very large transformers and where I was going to fit them, how I was going to fit them. The other problem was coming up with this. Now I actually had one other problem, because at first I thought I did, because that filament supply I needed, let me zoom out so I kind of just show it a little more. I know it's probably kind of small, but bear with me here. Let me rotate you down. But I needed 1.5 volts decent current for these guys, 2.5 volts for the 27. These are 26s. I need 2.5 volts for the 27. I need 1.5 volt for this 26. And then 2.5 volts for these guys. Well, the two 1.5 volts is fine. And why do I need those? This has a separate hum control circuit. This is actually just completely a separate circuit, and with a separate hum control that they're controlling. So trying to put that in with the rest of these guys would not be a very good thing. Plus you also got RF on this side, audio frequency on this side. These are the cathodes. This is directly heated. So you actually would like to try to keep those separate. The other thing is, why the two different 2.5s? Well, these are self-biased with 775 ohms for a push-pull output. This guy is grid leak. That's what C3 and R9 is. It's grid leak biasing. It's detector. It has a hum control. There's the other hum control that's controlling just some hum that picks up off this AC coming in there. Even though it's indirectly heated cathode, it's still, there can be some hum there. And the other thing I want you to notice, somewhere in this line, there it is R1 and R3. These guys are actually self-biased by their own biasing resistor, which is R3 400 ohms, R1 20 ohms, right there. Which happens also, the resistance on this hum control and this hum control is both 20 ohms also across it. And of course there's the pilot light and so on. This is the out of the service manual. It's not quite correct for this one, this radio, because I have actually 5 taps off this power resistor, and then I don't have this little bit of filtering here in there, so I'm not sure which is newer or which is older. I do know that there's 3 different schematics I've found so far. There's this one. There is, let's see, which one is it? This one here, which is the radio I have. If you notice here, there is 1 resistance, 2 resistance, 3 resistance, 4 resistance, 5 taps. And that's that big blue power resistor. And we don't have that filter. There's a C12 and a resistor here. That's not in there. But also notice in the power supply here, in the primary, there's no fuse. But on this same page, out of Riders, there is another unit. Now it's using the other resistor like it shows in the service manual, and it has R11 and C12 here, this filtering thing, but it also has a 2 amp fuse in the primary here line. So it actually had a line fuse, whereas on the service manual they do not show that. There's none on this one. So there's at least three different separate schematics. And on these here, this one here and this one here, there's one less, well, they moved one capacitor out of one can and put it in a different can. Whereas on the radio here, the one I've got, it had, I'll bring it over here, it had this. They also have a little different values too, but it had this in here. There's five connectors. One is common, so 4 caps in there. And on this one, just like the other one, if I can find, yeah, right there it is. There's only 4 taps on it. 1 common, 3 caps, and they're different sizes. 2.5, 3, and 5 microfarad, where this one radio had 2 microfarad, 2 4 microfarads, and a 6 microfarad. So there were some changes done in that too. Now one last thing, and I know this video is getting pretty darn long, is the neutralization and how it's done. What they tell you in the service manual and the service documents, right off the bat, the first thing they tell you about doing it is you take a 26 tube. Of course, now remember, they wrote this for people back when you could go down to any place and buy a 26 tube. No big deal. But they want you to take a good 26 and cut one of the pins off, one of the filament pins. So you're destroying it. to use it, you plug it in where you're going to do the neutralization. Now, I don't, C2, these little caps is what you're going to be adjusted. So when you start doing it, each stage you do, you plug that modified 26 in. So you don't want it operating, you don't want it heat up. That's why you cut the filament line off. What you want it in there for is this capacitance between grid and plate. That's what you're looking for. Now they talk about doing that, and what you do is you do one stage and then you pull it out, you put it in the next stage, and of course put the tube back in there that was in there. Do that, and just, you know, there's 4 of them, so you do it 4 times. Excuse me. Then a little bit later in the writing, when you read further, then they get talking about, instead of doing that, or one other thing you could do is make you an adapter or get an adapter. And what the adapter is basically you make an adapter, you just get a, you know, if you have an old tube or something that's a 4-pin tube, you get the base off of it, and which I've got a few of those bases, and get the base off, and if you have, and get a 4-pin socket, tube socket, and you make up an adapter. Solder 3 leads on, 3 lines, you know, connect up 3 of them. Just leave that fourth one, the one of the filament leads, unhooked. What's important about that is, then what you can do is plug the adapter in and actually use the tube that's in the radio that's going to be in it running, you know, when it's operating. So you get to use each stage tube that actually would go in that stage without having to damage the tube. Well, if it needs neutralization, that's what I'm going to do. I'm going to make up the adapter, and that way I can use the tubes that's in here. I'm not about ready to destroy a good 26 tube to do this. If there was no other way of doing it, I'd figure out something. If nothing else, just unsolder the darn one filament lead right there on each one. It'd take a little longer, but I'd do that. Or put some heat shrink tubing over the pin or something. But anyway, that's, I think I've covered everything I want to talk about on this, and as I move along here, I'll be making videos of what I'm getting done and where things are at and stuff. And oh, one other thing, the speaker that was in this, and on the next video I'll bring in and show you, it's had a repair done. There was an open in the field winding, very on the very outer edge, evidently, because I can see where they tore back the paper a little bit or cut it back, and that covers it, and they tied the wires together and soldered them. But it's reading, you know, it's reading the resistance it's supposed to be, so, or basically what I believe it should be. There's no resistance readings on it or markings, but, and of course everything else is checking good. Now I have not checked these coils, but they're pretty simple, and I doubt, I visually looking at them, they don't look like anything's wrong with them. But the choke is good. This transformer is good. This one and this one is good. And I did check the continuity. Just ran an ohmage test on that field winding and the voice coil, and both of them were all right. So anyway, the only one other problem that it does have is this pickup right here. That coil is reading open. That's inside it. At least at the ends of the wires. Now I need to delve deeper into it and see if maybe where they're soldered on inside the head is broken loose or something. But when you measure the wires out there where they would plug into the radio, they're measuring open. So I'll have to go delve deeper into it. It's a real small, very small coil. I believe I've got a picture of it off another site. Yeah. It is, let me zoom in just a little bit here. Okay, it's this little coil right here, this little dinky thing, and this is not real large. Okay, so it's a pretty small coil. The leads come up underneath here and around, and they solder on up here, and then it feeds back the wires back. You got a horseshoe magnet here, and then the base here. The needle comes up through. Now I already knew there's a piece of rubber right here that the needle pivots right in here where the screw holds it in. There's a pivot right here. So as that needle moves back and forth, it basically changes what's going on here as far as moving the coil just a little bit. It just moves it a little bit in that field. And remember, moving a coil in a magnetic field creates electricity, and then that goes out to your audio amplifier. Well, to give it dampening so it's not bouncy or shocky or anything, they at the top of the needle goes into this rubber. Well, you can figure out 85-year-old rubber is rock hard, and it is, and that's usually what's the only thing that's wrong with these. And that you just take out 2 screws, they're right there, and just get you a piece of rubber and cut it and fit it so that the hole's there for it to go into. There's the coil. The needle goes into this. There's a pivot right in here, armature pivot, and like I say, that thing moves back and forth, moving the coil ever so slightly in this magnetic field. Anyway, but at the other end of the wires, it's open, and so I don't know if there's a problem here, problem in the leads, problem somewhere along those wires. I'll have to go into that a lot deeper and try to find it. So yeah, okay, so that's where I'm at. We will be I'll let you know what I decide on that power supply chassis, how much further I'm going to tear it apart, and stuff. Of course, the top will definitely be painted, and these transformer cases has got to be painted for sure. And so I'll be getting to that at some point in the near future, and get it all back together and working, in good shape. Then we'll go to the radio chassis and get it cleaned up, lubed up, and there's at least 3 caps on it. I know that's going to have to be probably replaced and stuff. Oh, by the way, all the tubes tested pretty decently. The 45s are a little bit on the weak side. I kind of figured that anyway. But they're still alright. They're just into the green, but they'll be fine. So I think I'll end the video here. I hope I answered any other questions that might have been out there and stuff. And so if you have anything else, just comment and stuff. And I guess I'll see you guys on the next video. Thanks for watching. Thanks to my new subscribers. And if you like the video, give it a thumbs up. Thank you.